Hi, my name is Sam, and along with Nosa, we will be looking at the security of wireless sensor networks. So, what is a wireless sensor network? A wireless sensor network is a network that consists of spatially distributed autonomous sensor devices. These sensors or nodes can monitor different physical and environmental conditions such as temperature, sound, vibration, pressure, and pollutants. Now, for the components of wireless sensor network, it consists of sensor nodes, and these are individual sensors that work together to detect and process some input, which can wirelessly transmit the data to a base station. The base station itself, which gathers the sense data for visualization and analyzation, which sends the results to a remote server application. The gateway, which retrieves data from sensors and provides a way to monitor and configure the individual nodes remotely. It also acts as a network coordinator for all of the nodes. Then there's a patch network, and these are nodes are spread out in different regions. Each region is equipped with a gateway for communication to other networks. And finally, there's the transit network, and this is an intermediate communication channel through which signals are forwarded to the base station. Now, our problem description is that there is a limitation of resources, which makes implementation of security mechanisms more complex than in a traditional network. To protect from attacks, a secure system needs to be developed to achieve secrecy of credentials, operation safety, and privacy of people in the sensor environment. And also, various attack methods can be easily performed on a wireless sensor network due to the lax nature of security on these networks. So wireless sensor networks are prone to security threats due to several factors such as range of radio transmission in the network, skeptical communication, the abandoned nature of sensor nodes, and easy access to the network. And continuing on with that notion, developing a secure system for a wireless sensor network must satisfy several security requirements or security goals, and they are confidentiality, which is restricting access only to authorized users and hide it from possible attacks; integrity, ensuring that the data and the resources are trustworthy; authentication, which is identifying a user and providing them with the needed access; availability, ensuring that the sensor nodes are available to provide their resources to the network; data freshness, this detects and discards duplicate messages and verifies that the information received is new; time synchronization, this is so that nodes can perform collaborative tasks; self-organization, nodes should have the ability to self-heal so that it can adapt to the various topologies; and secure localization, sensor network should have the ability to sense and resolve faults on the network securely and accurately. So our goals for this topic is we would like to identify various attack methods, also explain how these attack methods are possible, and finally provide suggested countermeasures that can be deployed that can harden wireless sensor networks and protect them from said attack. So the three attacks that we're going to analyze is going to be a black hole attack, which is a malicious node uses its routing protocol to block packets from forwarding information to a base station; a Cybele attack, in which an intruder forges multiple identities to access data meant for the identities forged; and then a denial of service attack or a DOS attack. And this is where an attacker tries to restrain access to network services by consuming all of the resources. So the first attack we're going to look at is a black hole attack. So in a black hole attack, a malicious node uses its routing protocol in order to publicize itself for having the shortest route to the destination node. The malicious node is aggressive and publicizes its availability of fresh routes regardless of checking its routing table. In this attack, the attacker node always has accessibility and replying to the route request, which can intercept a data packet and drop it. A black hole attack can be summarized as a denial of service attack. The only thing that sets it apart from a generic denial of service attack, which we'll talk about later, is it depends on a malicious node being a part of the wireless sensor network itself. And now we're going to go into the effects of a black hole attack. Since the network makes decisions depending upon the nodes which are intercepted and dropped, the result of a black hole attack is failure of the entire network. Black hole attacks also can lead to high latency and low throughput. through the sensor network. And in this image here, we can see an example of a black hole attack where we see the affected nodes communicating with the black hole node itself, which in turn talks to the base station. So we see here this is a high quality route. So if we go back to the previous slide, here we talk about, where is it? Since here we're calling it the shortest route to the destination node, but in this it is the high quality route. So because of this, the affected nodes are, their routing tables are pretty much flushed by the black hole node itself, and that's why we can see that the affected nodes are now routing their traffic through the black hole node as if they were a legitimate node or the base station itself. And now for the black hole attack countermeasures. One technique to protect against a black hole attack is by forming clusters where a cluster coordinator senses the existence of an intruder in the network and removes the compromised node. Another technique that can be used is the implementation of an active trust scheme, which resolves black hole attacks by using active route protection. A third technique that can be used is the implementation of the reward technique. Reward is a routing technique where a wireless sensor network is organized as a distributed database to detect a black hole attack. The next attack we're going to look at is a Cybele attack. So if we go back to the previous slide, sorry about that. Cybele attack is a, come on. Come on. Okay. So I'm sorry about that. A Cybele attack, and this, an intruder forges multiple identities to access data meant for the identities forged. So in this attack, Cybele nodes are connected to honest nodes via attack edges. These attack edges are difficult for Cybele nodes to create, so there are a few of them. Cybele nodes and honest nodes are completely isolated and connected by a few attack edges. Cybele guard checks a suspected node, and if it is verified once it is considered a trusted node, a successful Cybele attack will present a Cybele node as a legitimate node by framing or abducting the identities of genuine nodes of the network. Now, the effects of a Cybele attack can be seen as follows. A Cybele attack is a threat to geographic routing protocols and degrade the efficiency of fault-tolerant systems. A Cybele attack leads to miscommunication about the location of different nodes. A Cybele attack creates false routes during communication that violates the routing algorithms and fairness for the network. So we can see that here. So we can see the compromised nodes and the Cybele node itself, how a normal node is communicating through these Cybele nodes and compromised nodes as though they were honest or trusted nodes. And this also shows us the miscommunication that occurs when this happens, because it is again messing with the routing of honest nodes to other nodes. Now for the countermeasures of a Cybele attack, the simplest way to defend a wireless sensor network from a Cybele attack is to authenticate and encrypt sensitive information on each sensor node of the network. Another way to defend is to share a symmetric key that is unique for each node in the sensor network with the base station. That, in my opinion, is probably the best countermeasure, because in that situation you have a key that is the same but also uniquely identifiable to each node. So you have a symmetric key that represents yourself, and the base station holds that symmetric key also, but it is unique to you, so it's not the same for all of the nodes. And that is one surefire way to protect against forging, pretty much. Lastly, proper authentication of each genuine node is crucial to eliminate Cybele nodes from the network. Now, the final attack we're going to look at is the tried and true denial of service attack. Just like any other type of network, it can be susceptible to a denial of service attack or a DOS attack. It Denial of service or DOS attack is a common attack where an attacker tries to restrain the access to network resources. The attacker swamps the network of the target nodes by flooding its communication link with a continuous request to deny services to legitimate clients. DOS attacks can extend through all layers of the protocol stack, and because of this, it can be difficult to prevent because of all the different forms it can take from inside a network. The effects of a DOS attack can be seen as follows. A DOS attack has an effect on the availability of a network by depriving legitimate users from accessing the network resources and exhausting them. A DOS attack can lead to a total network distortion in a wireless sensor network, as a DOS attack slows the network performance, increasing the delay in packet transmission and block the communication path between two legitimate nodes. And in this image, we can see an example of that. So in this instance, the attacker is DOSing one of these nodes. I don't. Oh, here we go. So the attacker is DOSing one of the nodes here, and as we can see, it trickles down to the next node, and eventually the base station. And because of this, it'll saturate the connection, and it could eventually boot off or prevent the other nodes on the network from being able to communicate with each other and the base station itself. Now for the countermeasures of a DOS attack, one way to defend against a DOS attack is by implementing firewall and router filtering. That way we could isolate this and block this node completely from the network, so there will most likely be some sort of address associated with this node, and with a firewall you can just block that itself. So since it is talking about the communication link, if we look back here, the communication link right here, so that should be layer 2, so it'll probably be a physical address that you can filter somehow. You can also use a cookie-based approach, which can also be used to help defend against a DOS attack by using a one-way hash function to verify that a connection request is legitimate. Also, by identifying and authenticating the traffic and resources in the network, a DOS attack can be prevented. So in conclusion, the growth of wireless sensor networks in recent years has increased drastically. Because of the constraints servicing the sensor network, the security needs to be upgraded to make it less vulnerable to attacks and to successfully accommodate the diverse applications that the wireless sensor network is capable of. Although several research studies have been done to counter security attacks, providing a secure sensor network remains difficult. And finally, new and robust mechanisms are needed to prevent wireless sensor network attacks efficiently. So thank you, and I hope you enjoyed this presentation.